To begin our study of mechanics and kinematics, we're going to start by defining several quantities that help us to describe motion. The first quantity we need is displacement. Motion is the displacement of an object from one place in space and time to another. So displacement is moving from one place to another. It's related to the distance traveled. In order to define displacement, we need to have a reference frame or a coordinate system. Mathematically, displacement is defined as the final position of an object minus its initial position. So on the left, delta x is the displacement. Delta is a Greek letter. We're going to use a lot of Greek letters in this class. Delta x, that stands for displacement, is defined as final position minus initial position. So let me show you how this works with an example. I'm going to have a car that is driving from, well, it'll be driving to several different locations, and we'll calculate its displacement as it moves through these different locations. And we'll draw a graph of its position versus time and calculate some of the displacements. So the first thing we need to do to describe motion of a car or anything is to draw a reference frame or a coordinate system. And in this week's materials, all the examples we're going to be doing are one-dimensional, meaning they occur just along a single direction. In the example I'm about to do, that direction will be horizontal. We'll also see examples that happen vertically, up and down, but all the examples this week will just be either purely horizontal, purely vertical, just happening in one direction. Later on, following week, we'll start doing 2D kinematics, and a few times this semester we'll even have 3D problems. So here's a reference frame. We need to have an origin, so that's 0 in the middle. We need to indicate a positive direction, so positive x is to the right, and I'll make some marks on the axis. Say we're measuring this in meters, so maybe 10 meters, 20, 30, 40 meters, and same thing to the left, negative 10, negative 20, negative 30, negative 40. And let's say that we've got a car driving along. This is a road, and we've marked our coordinate system along the road. And the car starts out at 10 meters. So here's my poorly drawn car. And we'll say that that starting spot is labeled location A. And now this car drives to location B, which will be at 30 meters. All right, so the car drove from location A to location B, and now for some reason the car decides to back up, and it backs up to location C, which is at negative 20 meters. Okay, so the car went from B to C, it just backed up. So this is the motion that's happened. The car starts out here, it drives to the right, stops and backs up, it ends up at location C. So let's start learning about how to describe this motion. We could, for instance, draw a graph of position graph this motion, let's say the car starts out at location A at time 0, which means it's at 10 meters at time 0. And let's say it takes 10 seconds for it to drive to location B. Location B is 30 meters, so at 10 seconds the car is here. So that's A, that's location B. And now maybe it takes 15 more seconds for the car to back up and end up at location C, which was at negative 20 meters. So location C would be negative 20 meters. After 15 more seconds, that's 25 seconds. So now the car is at location C. And these are the only data points that we know for sure based on what I drew. Maybe you make a careful measurement of the car's position versus time, and it ends up looking something like this. Okay, well now let's do some calculations of displacement. Let's find the displacement from A to B. We'll just use our definition. Displacement equals final position minus initial position. Now, here's something that you need to get used to in this class. This will come up a lot. I use these labels final and initial. Textbook uses these all the time too. You need to understand the context of what final and initial mean for the question that's asked. For this particular question, we're trying to calculate the displacement from A to B. So for this question, initial would refer to point A, and final would refer to point B. Final does not mean point C, because that's not what the question's asking. So you need to interpret these symbols a little bit. You need to use some common sense and make sure you're answering the question that's being asked. So for this particular question, the displacement from point A to point B, use your common sense, realize that final is referring to location B, where the position was 30 meters. And initial was referring to position A that had a position of 10 meters. So that equals 20 meters. And that's a positive number, which means that the car has moved in the positive direction in this coordinate system, which is to the right. Okay, let's do another one. Let's calculate the displacement from B to C. All right, same definition, delta x equals x final minus x initial. But keep in mind, you need to use your common sense and choose the appropriate values for final and initial. Because now, in the question I'm asking, calculate the displacement from B to C. C is the final state. B is the initial state. So for x final, we use the position at point C, which was negative 20 meters. And for initial, we use the position at point B, which was positive 30 meters. notice when you do that, you need to keep careful track of the signs. Negative 20 minus 30 is negative 50 meters. This negative sign is important. It's telling you that the car moved in the negative direction with respect to this coordinate system that we drew. In this coordinate system, we said that to the right was positive, which means that to the left is negative. And certainly when the car goes from B to C, it's moving to the left, and it's moving a distance of 50 meters. So that's how you interpret this answer. In physics, negative and positive almost always correspond to a direction. So this is a little different interpretation of negative and positive numbers than you may have learned in math class. This is really a vector. The fact that this is positive 20 meters means 20 meters to the right. Negative 50 meters means negative 50 meters to the left. Those are vector ideas. This displacement carries a magnitude, a unit, and a direction. 20 is the magnitude, meters is the unit, to the right is the direction. 50 is the magnitude, meters is the unit, to the left is the direction. So just for practice, see if you can calculate the displacement from A to C. And I'll give you the answer. It's negative 30 meters. See if you can get that on your own.